Thanks to be here for this talk. I'm Nicolas Fränkel. I actually rarely do speak in French, so I'm very happy. This is my first time here at Riviera DEV. For a long time I was a developer, a team lead, an architect, whatever. And then I had enough of like stupid project managers, stupid customers, stupid deadlines, and all that stuff. Now I'm just a regular DevRel. So the good thing is I will talk to you, I will try to tell you stuff, and if you don't listen to me, that's fine. Great. So as I mentioned, I've been a developer, but I also have done some other stuff, and I worked at the UNEDIC DPI, UNEDIC DPI, in Montpellier. Who knows about that? One person, yeah. Two persons, two people. Well, actually, that's the organism in France that's supposed to pay out the unemployment stuff. So they have lots and lots of money. And because it's a bit critical, right? They had to be very, very keen on monitoring. At the time, we didn't talk about observability, it was talk monitoring, right? And they had these like huge screens on the wall, and they were super happy to tell it was the biggest in France, if not in Europe. I don't remember well. And basically at the time, oh, it's gone. And it's gone. And it's back. So hopefully, this is a display problem, or should I change the result? Oh, no, okay. And yeah, so basically there were a bunch of people like watching all day, and if something happened on the dashboard, they were supposed to intervene right on the spot. And it was an easy system, right? And now all, or if, well, not all, but most systems have become distributed. So just monitoring and looking at the dashboard on the screen might not be enough. So that's why we invented a new term called observability. Just for the record, I am a developer, I'm not an ops, so this is, I'm talking as a developer to other developers, so you can help your ops colleague. So if there is, are there any ops in the room? Please don't judge me. Okay, great. So this is the definition of observability by Wikipedia. And basically, it's based on 3 pillars: metrics, logging, and distributed tracing. My talk is mainly focused on distributed tracing, but still I believe it's a whole, so I will just have a couple of slides on the 2 previous points. So metrics, I believe this is a solved problem. We have been doing that for a long time, like watching CPU, storage, whatever. The only thing that we need to do is to have higher level metrics. And most of the companies, of the serious companies, they are already doing it. So it's the same. You just need to have like a bit higher level metrics, but all the infrastructure is there already. Logging is interestingly a bit harder. Like a couple of years ago, I did a talk on logging, and it was amazing to like see that most developers didn't care or didn't realize that it was very important. First thing first, what do you log? Do you log manually some stuff, or do you log automatically? So when I was young and foolish, I thought, wow, I have a very good idea. I know about the Java agent. I will log every entry with the parameters and every return value. Right? That was very smart, right? No, not really. So basically, yes, I had a kind of distributed tracing, but that was not really that great. On the opposite, if you do manual logging, you need to be very careful to have guidelines, and then you need to check during the code reviews, and it's a lot of effort to have like the same kind of logging quality across all your software. And the formats. When I was young, which was a long time ago, we actually like logged into the production system, we looked at the log. Nowadays, it's not the case anymore with the cloud, with the like microservices or whatever. You just need to have an aggregation of logs. You don't connect to the machine. And so the logs is not meant for a human to read, but for a machine to read. And so having a JSON formatted string is a good idea, because otherwise it means you will need to have an additional parsing step somewhere. Where to log is also an interesting problem that changed. When I was young, it was you shouldn't log to the console. Everything must be in a file. And nowadays, it's the complete opposite. We have containers, and now we log to the console, and then something scraps. And as I mentioned, like, you need to have a log aggregation solution. So I'm most familiar with the Elastic Stack, but basically you can have anything, and all of them are more or less the same. First, you get your hands on the log, so you need to think whether you push the log or you scrape the log. Then, if needed, but you shouldn't, you pause the log, then you store the log, which gives you another interesting problem. How long should you store the log, and how much does it cost, and all these questions. Then, of course, you search, because at that point, you will be interested in the logs because of debugging and display. And, well, I believe most of you are familiar with one solution or another. Now comes the real interesting problem, like tracing. This is also the Wikipedia definition. In general, I love Wikipedia definitions. This one, I don't like it so much, so I came up with my own that was probably inspired by many smart people than me. And basically, this is it. How do you trace a business transaction across several components in your information system? And I must really point out that it's not only about microservices. Most of you, all of you are doing distributed systems, even if you are not doing microservices. I mean, an app and a database is a distributed system anyway. And most of the applications we are working on are more complex than that. So even if you are not doing microservices, and you probably shouldn't, you are doing distributed system anyway. And in the good old times, there were only 3 actors there, like Zipkin, Jaeger, and OpenTracing. I will go back to OpenTracing. But basically, nowadays, we should have standards. We should have specification. And not like in the XKCD comics, hey, there are 14 competing standards. I will write one to rule them all. And now you have 15 competing standards. But a real standard that is really useful. And for that, there are a few bodies that have the kind of, say, power to enforce, or at least to lead people to do that, and one of them is the W3C. And the W3C created a specification called trace context. Basically, it's really simple. It defines 2 things, 2 concepts. The first one is a trace, and the trace is actually the business transaction that flows across components. And then there is a span, which is like the flow of a trace inside a single component. It's really bad, because I always notice the cameraman or woman, and yeah, it's not very natural. I'm sorry for that. So if I do the diagram, because the other might be a bit abstract, then you've got here, you've got the trace, and then you've got 3 spans. The first in X, second in Y, and the third in Z. So here you can see that the Y and Z components, they have as parents the X span. So this is a specification only for that. That's really not hard technical science. Then, after the specification, we must have something to work with. The specification is not good enough. And for that, finally, we have OpenTelemetry. And the idea of OpenTelemetry is it's a collection of tools, of, again, specification, of SDKs to help you do distributed tracing. Whatever stack you are using, unless it's a very rare stack, they provide one SDK for you. So it implements the W3C trace context, and I believe it's really interesting that it's one of the few open source successful merging in history, like open census and open tracing merged to create OpenTelemetry. And that is really, really nice. And of course, it's a CNCF project, it's Apache v2 license. Well, it's really, really nice. The architecture of OpenTelemetry is actually very, very small in itself. What it defines is the OpenTelemetry protocol and the OpenTelemetry data format, data exchange format. All the rest, it's the responsibility of the provider. So basically, you can also have SDK or whatever that allows you to like send data, but not much. And here it provides you as a courtesy the OpenTelemetry collector, but you can use your own, or you can use one that is provided by Zipkin or Jaeger. They are compatible. What happens afterwards here, it's not the realm of OpenTelemetry. They don't care. And that's what I just said. Now, as a developer, how can you help your ops colleague or yourself if you are doing the debugging of distributed system? Well, you have basically two approaches. The first one is auto-instrumentation. With auto-instrumentation, you rely on the runtime and you say, there is something magical, and like I did before, you actually automatically trace the beginning and the end of whatever. Then it sends the data. That's actually very, very easy, especially in Java. We'll see it's a Java agent. It's really, really easy. Otherwise, you can use manual instrumentation when you need more details or when you don't have a runtime. Then you need to get your hands on the SDK, and then you need either to use annotations or API calls. I believe if it's your first step, you should do auto-instrumentation because it's like not expensive at all, and you actually will reap the benefits directly. Then only then, when you need more details, when you want more insight, then you might want to delve deeper inside. But then it means that your developers will need to get involved, which might not be a great idea at the beginning. So here I have a demo, and my demo is very easy. So this is supposed to be like an e-commerce scenario, but, well, simplified. So I have like the user, it calls the API gateway, then the API gateway forwards the call to catalog, and the catalog searches in the database for all the products, and then queries the pricing service and the stock service. And the good thing is, everything is in the different stack. So here, I will be using Apache API 6. Here, this is a Kotlin Spring Boot app. That's really strange. Here, this is Python and Flask, and here, this is Rust with Axum. Who here is a JVM developer? Not that many. Python? Okay. Rust? Okay. So I will skip the Rust part, which is fine because that's the that's the part where I'm least comfortable. And it's gone. Wow. I don't need to touch anything. As I mentioned, the entry point is the most important one. It will generate the parent ID with nothing underneath. In the talk, I will use Apache API 6 because I'm working for Apache API 6. Who knows about Apache API 6? Great. Thanks, Antoine. So this is an API gateway. It's an Apache Foundation product. So basically, you have all the guarantees of the Apache Foundation. It's based on Nginx. Who knows about Nginx? Wow, It's a developer room, but there are many people. That's really cool. So Nginx is really, really good reverse proxy, but actually it was designed at a time where switching off and on again was not really an issue. And sometimes you want to change the configuration, and you want to keep your reverse proxy up. So on top of that, there is something called OpenResty, and it allows you to script the change of configuration of Nginx. And then afterwards, you've got the Apache API 6 layer, and then we offer a plugin architecture. Great, I will do the demo now, and now I need to remember that it's very sensible. Can you hear me? I'm a bit afraid that if I touch something a bit too hard, this display will switch off. So first thing first, I will start the stuff. Docker compose up. And the second stuff is I will describe everything. So close all. And here. So here is my Docker compose file. Everything is on GitHub, so you will be able to play with it. I have actually two versions. The first version is I already built the image. The second version is, well, it builds when you launch it. So for the demo, it's easier for me if I do like this. As I mentioned, I have Apache API 6. It's not the latest version. The latest version was released last week. So sorry, it's not up to date. Then I have the catalog. The catalog, I will show you the app, the pricing, and the stock. And then as for the OpenTelemetry collector, I'm using the Jaeger image because it's all-in-one. I don't care how many components are inside the Docker image. It's just like super easy to use. I'm trying to migrate to Grafana, but it's not that easy because I've seen that in Grafana, you can actually move from the metrics to the logs to the traces. And it's really, really nice, sorry. But I still have issues, so for the moment, it will be only distributed tracing with Jaeger. The catalog is Spring Boot application with Kotlin. So it's reactive because everything needs to be reactive even for a Hello World demo, right? Nothing mind-blowing. The pricing, as I mentioned, is like an app. And here I was too lazy. I just hard-coded the values. So the pricing is hard-coded. This is a Flask application. Nothing mind-blowing either. And I mentioned Rust nobody cares about, so I will leave it at that. Unless somebody really, really wants to see it. You really want to see it? No way. Okay. The important stuff, whether it's the Kotlin, Spring Boot, or the Flask Python, you can see in the dependency, there is nothing, but really nothing, that is OpenTelemetry. Like the really good stuff is that my devs can do their work and not be bothered by OpenTelemetry. However, when I build the image, so I build the image, it's a multi-stage Docker build. So first I'm building the image and then I'm running the image. But before I run it, I get the OpenTelemetry Java agent, and when I run it, I pass the jar that I just downloaded as the agent. So separation of concerns, your developers, they don't care. They just develop as usual, and then the person who does the build, who creates it, then just add the OpenTelemetry. This is the auto instrumentation. Costs nothing again. On Python, it's the same. Here, nothing OpenTelemetry. And here, during the build, I add the dependencies. And now, everything is as started. And I can curl local hosts. So here I go through the API gateway and I call the products. And if I go on Jaeger, so I will refresh Jaeger, I can find the trace. And be careful, it's magic. Here is my whole trace, and I have several spans, at least one per component. So we can see, let's see the system architecture, the DAG. So what we can see is the first call will be from API 6 to the catalog. The catalog will forward, like ask the stock, and then it will ask the stock directly, but it will ask the pricing through the API gateway. Perhaps, yes?
I missed something here.
Yes.
How do you flow the code through all services?
That's the thing. Okay, that's a good question. So basically, it's auto-instrumentation. Somewhere, there is code that basically when it receives the flow, it intercepts it, and it sends it to the OpenTelemetry collector. In my case, this is Jaeger. So every time, in every component, it sends it. So I have all the data in Jaeger, and then the UI just display it in a way that is like visible to me.
There is no correlation.
There is no?
Correlation.
There.
It means when you have several services, you have to know that this trace belongs to one thing, right?
Yes. So here I can see here. Okay. Let's go step by step. Here I know this is Apache API 6. Why? Because everything that is instrumented in Apache API 6, and in that case it's not instrumented. So here in API 6 I have like configured the service name to be API 6, right? And then on API, there is a global rule, meaning that every route will be by default like instrumented with OpenTelemetry. Something that you should never ever do, but that I did in the demo, is I have a sampler and it's always on. You should never, of course, have it always on because there will be too much data. For the demo, I don't want to send like 100 and 1,000 requests to get one trace. So I have it always on. Does it answer the question or not? Not. Okay.
Maybe I can rephrase.
Yes.
I mean, you have several services on the UI, right?
Yes.
And all these services are linked to one trace.
Yes.
I don't understand how.
Okay. Okay. So I prefer to walk when I answer questions. So it's about the W3C trace context. So basically, when I receive an HTTP request, I also have the trace and the span ID of the parent. So when I send the data, I just generate a new like child span, and I send everything.
Okay, so this is part of the Java agent, for example. It will.
Exactly.
Okay.
This is just, yeah, it appears like magic because it's the job of the Java agent.
Okay, got it.
If you have questions, feel free to ask them. Something that might be interesting. So as I mentioned, the catalog calls the stock directly, but we go through Apache API 6 to call the pricing. Perhaps it's on purpose, perhaps it's not, but it also allows you to check that your sequence of calls is correct. What we can see as well is that here I have a get call to the pricing and a get call to the stock that run in parallel. That's good because in my Java code, I use coroutines and I suck at coroutines. I never understand the context or whatever, but here, this is what I try to achieve. So basically, I wanted to run those two calls in parallel, and this is validated. So you can see it graphically that I didn't do any bad stuff. So even if you are not using it in an ops environment, it can give you a pretty good insight. I don't understand why it's red now. Okay, anyway. And, well, that's already something, right? What we can do also is on every call, we have additional tags. So they can be configured depending on the components. For example, here on Apache API 6, I asked to have the route ID, which in this case is not very interesting, the request method, a bit more interesting, and an HTTP header, and we didn't pass any. So let's do it again with a HTTP header. And now it's X, hotel, key, hello Riviera DEV. And if I search, now I have a second trace. So I have additional data. That can help you debug or whatever. You might be interested in having like traces only with this or this header. But every component gets the same. So by default, the rest I left by default. Okay. So the get method, the route, whatever. On the pricing, I think to remember here, that's also interesting. So the Python stuff, understand it's called by Reactor Netty, which is the Spring Boot application, because I'm using reactive. So you've got this sort of information all the time. And that's auto-instrumentation. So basically, I did nothing, low-hanging fruit. Now let's say that I want to have more insight. So I add manual instrumentation. I would start that stuff and describe the code afterwards. Great. So now my catalog, I have added one additional dependency. So I'm using the annotations here. And the annotations, I've set them on several methods. So previously, for example, oh no. Yes. Yes. It's a bit stressful. So here previously, this method, for example, was not instrumented because it was a private method. So no proxy, no whatever. And I want it to be instrumented for whatever reason. Okay, no worries. I just add this annotation with span, and then I will have it instrumented. I want to have the product ID. Here, I add an additional parameter, which is, in this case, normally would be pretty stupid because the product ID is part of the product. But because I'm using annotation, I have to change the method signature just to be able to add this annotation. And as you can see, this ID is not used. But at least it will be instrumented. On the Python part, I am using the API just because I can. So likewise, I have added the dependencies. So now my developer are aware of OpenTelemetry. And I'm using the API itself. And so inside a method, I'm creating a new span. And basically, this span is select star from price where ID equals ID. And I pass the product ID as the ID. How does it work now? Who is dying from heat? Yeah, let's keep it short then. So previously I had 20 spans, now I have 27, which is normal because I have more data. What did I add? I think it was the fetch one. Yes, the fetch one. So this is not auto-instrumented. This is something I added manually. And here you can see that I have the product ID that I'm asking. By the way, my code is pretty stupid because I get all the products and then I call the dependency, the pricing and the stock one by one, which you should never ever do, but yeah, it gives a nice trace. And then on the Python stuff, you see I have this additional span that I created myself and where ID equals 1 as well. So we can also see that the ID of the catalog, of the pricing, of the stock is the same in all components. You might have subtle bugs where, for whatever reason, you change the product ID. And that's all what I wanted to show you, since you are not interested in Rust, which is a good thing for me. So yes. It's very easy to start helping your ops colleague with OpenTelemetry. Just use auto-instrumentation if you're using a runtime. So Python, Java, I don't know about Go, but runtime means you can have an agent, an interceptor, whatever, and this is provided by OpenTelemetry. So just do it, it costs nothing, and it can help you a lot. Afterwards, when you want to have more insights, more details, more whatever, then you can start to bother your developers by using explicit OpenTelemetry, either with annotations or with the API. Thanks for your attention. You can follow me on Twitter, even though it might be dead tomorrow. You can follow me on Mastodon, and if you are interested about the GitHub repo, everything is on GitHub. So I have a bit.ly link to check if somebody actually opened the link. And if I got you interested in Apache API 6, then have a look. It's an Apache API gateway, the Apache way. And now we have 7 minutes for questions. You can take the microphone. Take the microphone.
Should the question be in English or in French?
If you feel more comfortable in French, sorry, but I will try to rephrase in English.
No, it's okay, it's okay. You were talking about the sampling frequency at the start, about setting it at always.
Yes, the sampling.
The sampling, yes.
Yeah.
The sampling frequency. What is a good frequency for you?
And the answer is?
It depends.
It depends. There is no good or right answer. What I would probably tell you is that at the beginning, you should probably overdo it,
yeah,
and then lower it afterwards once you are more comfortable. But it really depends. It depends how much money you have, because then it increases the traffic and whatever. Really, without any more understanding of your environment, I cannot give you any. You can start with, let's say, 1%. 1%.
Yeah, and about performance, the difference between a 20 and 40%, for example, is it this heavy?
It depends. Now, I always have this question about performance, and it really breaks my heart every time. I was always interested in ops stuff, even though I did developments, because in all of my projects, basically, hey, this is a non-functional requirement, right? So who is going to pay for that? Nobody wants. But then when there is a bug, so when the actuator, the Spring Boot actuator, was provided, I was really super happy, and I did many talks on the actuator. I wanted people to use the actuator. I wanted people to know about the actuator, and I always had this question, like, what's the performance overhead? And my at the beginning, I said, you know what, it's better to go very fast with your eyes blindfolded or to go slowly. But I understood that it's funny, of course, but it doesn't answer the question. If you're really at this level, then you should do your own performance tests. The question, are you already doing performance testing on regular applications?
It depends.
It depends. So if it's critical for you, you will do performance testing anyway. If you are a regular company, and I believe most people are regular companies, it's not going to change your life.
Okay. Thank you.
Hello.
Hello.
A small question about what you can find. So for example, imagine that we have a database that answers correctly for 99% of the time. Is it possible to find that at one time the call takes longer for whatever reason and trying to see what's going on the system? Is it something that you can find with this kind of stuff?
So what will happen is you will notice a bug, then you will check the Jaeger or whatever UI, and then you will find one of the spans that actually mirror your problem. And then you will see in which place there is an issue. It's not going to be fun, of course.
So you need an entry point to get to the log, right? You need an idea, something like that to start.
No. You can actually check. So probably you know at what time it happened. So here you have the time. So you can probably search for a couple of them, and then you can compare them side by side. So you can compare the right one and the wrong one. Oh, sorry. Thanks. I love sharing. So yeah, you can compare trace by ID. So if you find the time, so here you will say, hey, it happens like around this time. You find perhaps 10 traces. You can look at them and find the right one and the wrong one and compare them and check what the difference, where the issue happened. And then, as I mentioned, if you are using something a bit more, here it's only about distributed tracing, but you can go to the logs and to the metrics and perhaps see some correlation between them. It's not magical either. Huh?
Yeah, but I believe also that it's possible to find the correlation between these spans and the logs, right? I mean, at some point we need some correlation.
When I manage to set up Grafana, I can show it to you. At the moment, it doesn't work, so I cannot show it to you. If there is any Grafana expert, by the way, I'm interested. Thanks a lot.
If I can add some information, because I never played with Jaeger, but I played a bit with Tempo, which is the Grafana equivalent of Jaeger. And they started by the logs, actually. So the primary way of finding the traces was by the logs. Most of the tools that support tracing out of the box log the trace ID in the logs. So if you know how to manage your logs, how to find the line where you see something is wrong, you can find the trace. That's quite useful. And there's also some tools that can, like, you can search for spans that last more than 2 seconds or stuff like that. So you can find some problematic traces like that. Yeah. You have, at least with Tempo, you have some ways to search into your traces. That's really powerful. Yeah. Sorry.
I'm trying to show you what I did with Grafana, but it's like under. It probably won't work, but at least you will see where I'm stuck. And here, that's a bit more complex. The Docker file, it becomes like really complex because now it's not only about one single image, which I really loved in Jaeger, but then you have like Grafana, Tempo, Loki, and Mimir because I have like logging and whatever. And now I need to remember it's explore. And then I can run the query. And I search for a service, and it doesn't work. That's the problem. The problem is I don't know. So first, I don't know the tool enough. I didn't play with it enough. And then I don't know if I already have something, because perhaps something was not set. Perhaps I didn't.
Yeah, I guess you don't have any traces.
Yeah, sorry for that. That's really live demo. If it fails, it's live. Other questions?
Yep. Here. A question, it's a follow-up question with the first one about the sampling. Is it possible to set the sampling to 1 or 2%, but do some kind of canary testing? So if I add an header to a call, to sample it every time, just because I want the trace for this one and or not the others?
So at the moment for Apache API 6, it's not the case. You can open a feature request. At the moment, to be honest, it will be hard. If you do the code by yourself, it will be much easier. The feature that I really became interested in, like sampling, and basically right now there is something that you sample everything and afterwards you decide whether you take it or not. Well, if you have resources, it's good. It gives you a lot more insight, but of course you need to spend all the resources first. So it's also a way to do it.
As I can see, you propagate the tracing ID in HTTP header. And what about other protocols, non-HTTP?
So it's a good question. So what about asynchronous messages, message queue, Kafka, whatever? So it's not part of the W3C. I didn't play with it, but I think that in OpenTelemetry, there are stuff for this. So basically, you can propagate it not only through HTTP. It's outside of the scope of the trace context propagation, but it still should work. But I didn't play with it, so I cannot commit. I think it exists though, because I checked, but you really need to try it by yourself.
I also have a question. Is it possible to export the trace for the use case where, for example, you are calling third-party apps, and you want that the third-party apps also expose their traces? So other trace that go to third-party, because, for example, if a third-party also call third-party, they will say it's not us, it's them, and with the trace.
That's a good question, and I really don't know, because it's just an HTTP header. So basically, if the stuff goes through you, and then you call another one, but then they are like instrumented in another OpenTelemetry collector, for you it will be a dead end. It will just get you will get the traces back when they exit and they enter your information system. So in this case, it means you should share the same OpenTelemetry collector, which as an architect, I would feel very uncomfortable doing.
Yeah, because my point was probably if the third party and yourself had an OpenTelemetry was to retrieve their data, but not to do it on the same OpenTelemetry.
In the end, it depends on the storage. It really depends on the storage. So it might be feasible, yes. But honestly, again, what you are interested in is where it fails. So either it fails in your information system or in theirs. If it fails in theirs, then you can ask them, hey, do your stuff. Again, I don't know, it depends on the storage. The OpenTelemetry standard doesn't define the storage. That's the reason why I could use OpenTelemetry with Jaeger, because probably what they did, they kept their own storage, and they just added the format and the protocol, and that was all. Zipkin does the same. But underneath, it depends how they store and how compatible is the storage. So it's very implementation dependent.
Yeah, thank you. So I just have a question about other tools for instrumentation. Like, for example, we have Datadog who, yeah. My question is, in the case where we are going to only use like auto instrumentation, so basic usage, is there a real argument for using, for example, OpenTelemetry instead of Datadog, especially if we think we are not going to use manual, because the reason would be to avoid vendor lock-in in case we change. In auto instrumentation, we just need an agent, and we won't have a problem with vendor lock-in.
So I'm not familiar with Datadog, but as far as I understand, it's logging, right?
For APM, so it's also for yeah.
So then it's up to you.
Okay.
In my opinion, I prefer open standards. I work also on an Apache project. If you are fine with spending millions on Datadog or on any other solution, I have nothing against Datadog. They are a French company. No, not anymore. Never. So they are French. The founders are French, which is good. We don't have that many French founders. If you are happy to pay. That's very fine. Then he can come here and do talks. No, it's up to you. I mean,
because we can use, for example, OpenTelemetry with Datadog in some cases. But yeah, it's the real question I think is what can we do with one that we cannot do with the other? And I am not sure I have a
probably
question.
It's not the right way to frame the question. It's like Jaeger and Zipkin. Probably you can do the same with one or the other, or OpenTelemetry. The question is how much do you want to commit to a single service provider? And what is the cost of being able to move from one to the other? That I cannot answer. Depends on your company, depends on the risk you are willing to take, it depends on your resources, it depends on so many factors. Me, by default, I would be willing to pay a bit more to be able to change my provider. But a bit is very subjective, right?
Actually, Datadog supports the OpenTelemetry format, and also the Datadog collector support also this format, and it can get sent to Datadog platform in an OpenTelemetry format. So it's possible. Just the difference is that Datadog format has some more options, some more tools specifically designed for Datadog, but OpenTelemetry adds more and more feature. So it's possible even with Datadog. We have Datadog actually in my company to use the OpenTelemetry format. You want to add something? That's okay.
So for example, something very, very easy is you are already using Jaeger or Zipkin. Sorry. You are already using Jaeger and Zipkin and using their proprietary protocol and proprietary format. Then you just switch to hotel collector. And then you don't change your infrastructure. But then if something happens and you want to move to Datadog, for example, then it will be very, very easy. And it's time. If you've got more questions, I will be there until tomorrow morning. And thanks a lot for your attention and enjoy the rest of the conference.